If you place hand sanitizer onto a plate and then grab a paper towel, you can be successfully convinced that the paper towel will react with the hand sanitizer and create a flame, as you can see here. This trend has been going around and I wanted to debunk it. While it looks like the hand sanitizer is just there and then the paper towel catches on fire, you missed a critical scene. I'm able to edit out the part where I light the hand sanitizer on fire because hand sanitizer burns in an invisible way. You guys wanted me to show you what it looks like in the dark, so here you go. Like all science experiments, please don't try this at home. I'm showing you so you don't have to. As you can see, it burns blue, and now it's pretty obvious why the paper towel actually lights on fire. Did you accidentally make a mark on an important paper? Fear not, just grab a lighter and remove it. Wait, does this viral trend actually work? Well, yes and no. This clip is actually not edited, but as usual, you're missing something. This trick doesn't work on regular pens, it only works on erasable ones. Erasable pens are erasable because their ink is thermochromic, just like the paint used in mood rings and color-changing mugs. That means their color changes with temperature. The heat from the friction of the eraser is enough to change the ink from dark to clear, and if the heat from friction is enough, then the flame definitely would be. Legend has it that you can make your doodles come to life by drawing in the sink. So let's see if this is fact or cap. Theoretically, the marker is insoluble, so it won't dissolve in water, and then the buoyant force will peel it up. Now for the moment of truth, and it works. Now that it works, the next logical step is to try to draw a doodle bob. Ignore my terrible drawing skills and let me explain some tips I learned. Your porcelain sink needs to be clean and dry before you start. Then once you draw, you also need the marker to be completely dry. And your drawing can't be too big. Poor doodle bob here got stretched out like a medieval torture rack. I tried a few more times after this, but it was just too hard. If you add salt to water, and of course it has to be iodized, and then you add a battery, it can start to create a vortex. It takes a little bit of time, but eventually becomes obvious. Just kidding, this trend is completely fake. This is what it actually looks like and it's just put in reverse. However, if you do want to make your own vortex generator, you just need 2 2-liter soda bottles. You need to drill a hole in each of the caps and tape it together so that it's sealed, and then you give it a good shake and you're good to go. I wanted to try the vinegar and egg thing, so I picked the unhappiest egg from the carton and threw it in. It was a bad pour, but look at that surface tension. After a couple hours you could see some bubbles, and then when I came to it in the morning, the shell was almost completely gone. I think if I had left it in longer, the shell would have completely disappeared, but underneath it looks all spongy and weird, but apparently it's pretty fragile. Alright, so I've soaked the egg in vinegar for a couple days now and the shell is completely gone. Immediately when I took it out, it felt a lot more sturdy than it did the first time, but I wanted to push it to its limits. It survived the first drop test pretty well and can definitely be considered a bouncy egg. Unfortunately, however, if you drop it from much higher, it's disastrous. Sorry to wake you up with that, I just wanted to let you know that if you poke a balloon, it'll pop. That is, unless you put electrical tape, and then you can actually fit pretty large objects through a balloon without it popping. I think you can see it here poking through the other side, but when I take it out, it'll start to leak out. But as long as the tape prevents the hole from cracking and spreading through the entire balloon, causing it to pop, I can even stretch it out pretty well and it will never pop. Psych. You might remember the step on water challenge, and I'm not good at it, so I decided to make some oobleck to make it easier. Oobleck's a non-Newtonian fluid, so if you go through it slowly, it's like a liquid, but if you push on it hard, it acts like solid. This makes the challenge much easier, but if you're like my mom, you're actually skeptical that I'm not just hitting the bottom of the platform, so let me show you this cool looking bouncy ball as proof that it doesn't actually touch the bottom. In my last video I showed you that ink can be erased with flames if it's an erasable pen. That's because the ink is thermochromic, so it changes from dark to clear with a raised temperature. I wanted to see if cooling it down would change the ink back. After a few hours it wasn't showing promising signs, so I got impatient and just skipped right to dry ice. Sure enough, when I cooled the ink down by placing a block of dry ice on it, the ink returned almost immediately. Here's why you should never make a flamethrower with an aerosol can and a lighter. The principle works the same as a gas stove, so it seems like it'd be fine. Gas is released from the valve and then sparked externally to light the flame. As you've seen from my other videos, that flame propagates to the gas source at a fixed speed. If the flammable gas is traveling faster than the propagation speed, the flame will never reach the source. On gas stoves, the flame won't continue to propagate through the pipe even if it reaches the nozzle because there'd be no oxygen, which the combustion reaction requires. Unfortunately, like we saw in the San Bruno explosion in California, if you have improperly installed systems, an incredibly dangerous amount of gas can be ignited. The blast from the San Bruno disaster was large enough to register as a 1.1 magnitude earthquake on the Richter scale. The same applies to your home. If you leave the valve open but not lit, the gas will accumulate inside your home and can be very dangerous. So how does this relate to the gas canister? Well, unlike a gas stove which has a heat-resistant metal outlet, the aerosol cans are not designed for that at all. So if the heat damages the pressurized canister, that stored gas gets access to oxygen and could quite literally explode in your face. You may have heard that if you fold paper in half 42 times, it'd be thick enough to reach the moon. But is that even true? I tried it out and couldn't fold it more than 7 times, so let's do some quick math. The distance from the Earth to the moon is about 384 million meters, and paper is 0.0001 meters thick. Each time you fold the piece of paper, it doubles, So this equation holds where n is the number of folds. Plug in n equals 42 folds and you get around 440 million meters. So astonishingly, yes, this fact is true, although good luck folding it that many times. I'm going to use this trending experiment to explain a hot air balloon. When you light the candle, the hot air rises and then the mask acts as a balloon, and without any other outside factors, it can completely lift up the whole device. Okay, you may not have noticed this, but it's actually fake, there's string. But that doesn't mean this isn't how hot air balloons work. A useful tool to modeling fluid flow is to use Schlieren optics. And as you can see, the hot air rises because it's less dense. So if you fill a large enough balloon with enough hot air, then the buoyant force will be more than the combined weight of you and the passengers, and you'll rise. I saw this trending, so I wanted to give it a shot myself. I'm supposed to be able to remove this second block and it stays balanced. So let's see. Okay, alright, it actually works pretty good. In order for this to work, the weight has to be evenly distributed about the center. So I figured I can just keep adding blocks to the center and see how high I could get. I thought I was in trouble here, but ended up getting it. If you guys want to try this, duet me and see if you can get taller than that. This is a moisture meter for plants, but today we're going to use it to solve the question that's been on all of our minds. Is water wet? Now that we've calibrated it, this should be proof once and for all. I'm not sure how to interpret these results. It's not fully wet, it's kind of moist, and if it's moist then it's not wet, so let me know what you guys think. You may have heard that on Mercury, a day is longer than a year, but is that even true? Well, a day on Earth is how long it takes to rotate about its own axis, like this, and a year is how long it takes to orbit around the Sun. So on Earth there's 24 hours in a day and 365 days in a year. On Mercury, however, there's about 59 Earth days in one rotation and 88 Earth days in a trip around the Sun. This makes the claim seem false, but for anyone actually standing on Mercury, a regular day for them would be longer than a year. That's because Mercury orbits a lot more than Earth does for a single rotation on its own axis, meaning the Sun would be in a completely different location after one full rotation. This definition of a day as sunrise to sunrise would take 176 Earth days on Mercury. Does this mean everyone born on Mercury has the same birthday? Apparently, if a large enough sample size of people guess, the average of all the guesses will probably be pretty close to the actual answer. So comment your guess as to how much change this is. After about a day's worth of comments, I'll take the average of those comments and then I'll add up the change to see how close it is. Stay tuned for the result. Finally, the moment we've all been waiting for, the results. My friend helped me out in scraping the data from the comments of my last post. For the first run through, we kept in even the most ridiculous answers, and by the way, I do appreciate the resistance of negative number people. The trolls momentarily won, as the average of this value was ridiculously high, but then I just filtered out the absurd ones. And although this definitely introduced some bias, we'll say your guys' collective guess was between $17 and $20. By the way, I didn't want to skew anybody, but my guess is around $31.48, so we'll see. I'm ignoring the $1 coin since that's too sneaky, no one could have predicted. After just the quarters, we already had $21, and so adding up the rest, it just became a blowout. Follow for the next experiment.